All right, so hello, welcome to a new problem. Today's problem is A81, boats to save people. This is a medium problem, and I'm trying to do the LeetCode thing where you do it's like a monthly quest or something, monthly daily quest. So yeah, it's kind of cool, I guess. But yeah, we're gonna go through this with my problem solving process. This problem is I looked at it before turning on OBS and recording, and it kind of sounds interesting to do. It's not hard, but it's like kind of like a challenge and like an interesting challenge that kind of sounds fun. That looks kind of nerdy, but I don't know. But anyways, so let's go solve this problem. So you are given an array of people. You are given an array named people, where the people at I is the weight of the ith person. Okay, that makes sense. And an infinite number of boats where each boat, okay, so we're given an infinite number of boats as well, where each boat can carry a max weight of limit. Okay, so okay, each boat carries at most two people at the same time. Each boat carries at most, okay, provided the sum of the weights of those is at most limit, return the minimum number of boats to carry every given person. Okay, so let's just backtrack a little bit and just go make it slow. So we know that our input's going to be an array of ints named people, and let's say elements in that list. Element val is equal to basically the weight of said people. Um, and then we're given. It's not really a given. Um, I'll just make that a note. Let's make that a note right now. I'm thinking about. So the notes infinite number of boats. Okay. And then the output. Oh wait, no, we still haven't gotten the input yet, right? So, mm, 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 mm. So for our input, we also have the limit. So an int, then limit, or basically, let me do this. There you go. Boom. Okay, so an int limit, where limit is basically max weight of boat. Okay. So I kind of understand that. And then for our output is just going to be what you call it? The number of boats. Number of boats. Specifically minimum in boats to get all people on boats. Right? So that makes sense. To really showcase that I do understand this, let's go through an example. So let's go example one. Actually just make it that below the notes, because I like it that way. Example one. Okay, so let's say we have an input where this is the weight of the people. 2 0, well, 2, I'm pretty sure, can we have 0? That's actually a good question. So the question, can weight be 0? And then for another question, is it in sorted order? Right? So I would ask the interviewer this question because it just popped in my mind while going through an example. But in LeetCode, all you gotta do is scroll down. So the weight is cannot be 0. So no. Is it in sorted order? Um, Looking by the example, it's not. So no. Actually, just specify is it. So it means people wait. Okay. So no. Okay. So that's a good thing to note. We can take that, especially this one. It is in sorted order. Okay. So inputs 2 and 1, and then I guess the limit is equal to 2. Okay. So what you call it? So the output would be 2 boats because we would have 2 and then 1, right? 2 boats, right? Because two's already at the limit, so we have to put it by itself, and then 1 has no next, or has no like, one's by itself. That's like the last person that needs a boat, right? So they're by themselves. Okay. But what about let's do an example where like we have two boats and they're both full, right, with two people. So example two, let's say our input is, I guess you can make that 1 1 3 2 3 1, I guess. So and the limit is 4. Okay. So outputs, we can look at it any way where it's maybe like this, we can make this a pair or this a pair or this a pair first that we look at first. But in general, it's gonna come down to two boats where we can either have like 3 1 and then like, well, we're also gonna have 1 1. So yeah, that's gonna be it. It makes sense. It's just that the way of like, how should I do this, right? That's something that I need to think about, right? But let's go over some approaches so I can kind of showcase you what I'm thinking about. So let's go through some approaches. So what I'm thinking is that we can just basically make it like we can sort people by weight and distribute accordingly, I guess. We can maybe start from the distribute accordingly. Maybe starting from descending or no ascending maybe, and then check if dot next is um is less than equal to limit, right? And then like if so, then make a pair and skip to next pair, right? Something like that. I don't know. So that's how I'm thinking about. I'm not sure if that how that will work. Maybe I can do some binary search to denote like maybe there's like a I don't know maybe maybe if I that sort I can maybe do some binary search to like yeah maybe help with the amount of pairings I guess. Maybe also include binary search. And then what I'm thinking about binary search is that if I can find um to find where the least max is. So basically, if I was at a limit 4, and then this is binary search, right? So let's say example 3. Example 3. So our inputs, let's say we have the same amount of people, but like just added one more, right? So 3 and then 1. So let's just say this is sorted, right? So I would do basically, okay, you guys are a pair, go to the next one. You guys can't be a pair. Um that's okay. You guys can't be a pair. Wait, but the limit is 4. So actually you can be a pair, right? Yeah, so you can be a pair. Okay. That's interesting. So you can be a pair. So yeah, you would have 3 boats. But past this point, let's just say you have like 3, 3, 3, 3, 3, 3, 3, 3. Instead of checking if all of these are pair or could be pairs, we just say, okay, past this point where you find the least max, I guess you can, oh no, because you can't, yeah, the least max, then we can just count these all as their own boats. So length minus this index is equal to the number of extra boats we can have, right? Because I have infinite boats, right? So yeah, something like that. I think we can do that. I'm pretty sure we can do that. But the only thing that I'm gonna have issues with is this kind of casing where it's like, okay, so we found the min max, the minimum max, um, right? With our limit being 4, correct? And um, so yeah, so we found it. But what about to its left, right? So, I don't know, something like that. Um, so yeah, that's what I'm thinking about, right? But I'm not sure if that'll work because what if our limit's also like 7, right? And we had like 5 in there or something like that. And then I don't know. I don't know what I'm thinking about, but we'll just see what happens, right? I'll just fix it later on. So that's my approach that I can do. So let's go ahead and try to do that approach. So first off, we gotta sort the weight. So we can say people.sort. I'm sure it's people. Oh, we gotta plan first. Yeah, we gotta plan before we code. All right. So let's go plan. Well, we're gonna sort people. People that sort. And then why is there 0 there? Anyways. Yeah, so you can sort the people. And then oof. Let me try to think. I'm not sure if that'll work. Or the binary search thing will work. Because again of my example. Well, I think a better way to do it is we can basically, if we find that a pair doesn't work, right, we can stop there and say, okay, at this index, this pair doesn't work, so everything to the right of it is basically its own boat, right? So I think we can do that. So dot sorts, then for I in range, to like the length of nums, I guess. Oh, it's length of people. I'm gonna make p is equal to length of people, right, up to p. Okay. And then we can say, what should call it? So, if I, length of people minus 1, actually. Yeah. Because we don't worry about index, whatever it's called. Okay, so if, out of range. Yeah, out of range. So if, let me think. So if people at I, plus, oh, I gotta make it a while loop, actually. No, do I have to make a while loop? Because if I do this, I want to go to the next pair, right? But then I'll have to remove this pair. Then, so I have to like go like plus, be like plus that, whatever, or something like that. But I think it's fine. I think I just skip by 2. Right? Because I'm gonna break either way if the current pair doesn't work, right? Okay, so if p at I and p at I next, so plus 1 basically. So pi next. I like it like that. I wish I could do that. So then we're going to basically increment the amount of boats. So we're gonna say boats is equal to 0 right now. So we can say let's see, boats plus plus. We can say that. We can the amount of boats and move on to the next pair. But oh, if pi and pi next is less than equal to limit, right? We do that. And then from there we can basically say else if that's not the case. Then I guess at I guess that what you call it, like p minus I. That work? P minus I. Let me think. Okay, so if this was the case where limit was like 3, okay, and this was the length of the boats that we have right now. Okay, I mean the length of people we have. So this is one pair, so that's one boat. This could be two boats, right? But okay, so I guess we're currently right here, right? So we're at the second index. Okay, that makes sense. So we're at second index. And we know that from here we can't really make a pair. So we gotta say from here minus length. So length minus I, right? So length is 4 minus I, which is 2. So that'll be 2 extra boats. So yeah, p minus I. So boats plus equals p minus I. Okay, yeah, that makes sense. Okay. I think that makes sense. This will work. I'm pretty sure that this will work. And then in the end of this, once you break out this for loop, we're just going to return boats. Is that what I return? Yeah, the return number of boats, min boats. Okay, cool. So yeah, and then we got a break from here, of course. All right, so let's go and code that up. I'm pretty sure it will work with a small example. Like, it makes sense. It will never go out of range either. That will never go out of range either. Okay, so let's go plan that out. So boats is equal to 0. Oh, we gotta make an if statement. So basically, yeah, there can be only one person. So, okay, so for I in range. Okay, so if basically, so if p less than p is less than equal to 1, then we're going to return 1. Okay, I think that works. So let's see that. So both is equal to 0, and then we gotta sort the people. Let's sort, and then we gotta check. So if there's only one person, right, then that means that they only need one boat. Okay. Notification. All right. Anyways, so if p, oh, I didn't get p. So p is equal to the length of people. So we gotta say if p less than equal to 1, then we're gonna to return 1 boats, right? They only need 1 boat. But yeah. Um. Yeah. Okay. Makes sense. Okay. So else we go through for loop. So for I in range, um, all the way up to p minus 1. Yeah, p minus 1. So starting at 0 all the way up to p minus 1. Incremented by 2 every time because they're pairs, right? So if p at I, people at I, um, plus people at I plus 1 because dot next, right, is less than or equal to the limit, then we can say that they're a pair. So boats plus equal to 1. But else, in the case where a pair, like, it doesn't work, right? We can say we can make that pair. I mean, we can separate those pairs and make them all into separate boats, and everything after that its own boat, right? Because it's sorted, right? So p minus I, and then we can break. And then from there we can return boats. I'm pretty sure that's possible. So let's go run that. Okay, runs. That's cool. But I feel like I could do some binary search. But let's just see if that actually works. Wrong answer. Okay. So the limit is 7. So expected 2. Let me see why. But we only output 1. That's interesting. So I'm pretty sure it's because, let me think. Let's go through like a review part of it. So let's say our input is, I mean, we know our input's like 317, but in sorted it'll be 137, right? And then our limit is equal to 7. Okay, cool. So now that we know that, okay, I'm pretty sure it doesn't take in the 7 somehow because of this if statement, maybe. Okay, let's just go through it. So sort p is equal to 3. If p is less than or equal to, it doesn't go through this at all. Go through this for loop for starting at 0 all the way up to p minus 1. That's 2. Okay. Okay. So what I can do is I can maybe like out of range, that. So I can say maybe like, okay, so if I is equal to the if I is equal to p minus 1, then I can just say boats plus equal to 1 and then break. I can just say that. Then it should work for this case. Hopefully. Wrong answer. Wait, did I go over? That was hold up. I should have got the test case. I'm not sure if this works. I'm not sure. I feel like that should have worked. Because we've gotten 2, right? In this case, what happens? Okay. Okay. Okay, that's interesting. Um let me think about that. So just run it like this. Okay, so this was the 10th case. Okay. So I did pass it. Let's just use this test case and save it for later. Let me think. Let me think. So that kind of works for that case. P17. Well, it should still. No. P-1. Because we stop at, yeah, because it stops here. Doesn't take into account, right? So if I is equal to P-1, basically at the end. But then in that other case, it didn't work. Let's just try it here. So I gotta save these test cases. My bad. Okay. So that's a good case. Then what about what was the other one? Okay, this one. Okay, what's the issue with this one? I'm pretty sure it's because we counted something. That's another issue. Let's just take this one. So in this case, we'd sort it to 1, 2, 4, 5, and limit is equal to what? To 6. Okay. Yeah, we would need wait, 2 boats really? 1. Oh shit. Oh damn. I just realized. Okay, so a pairing could be this 5, 1, and 4, 2. That's why it's 2. What the heck? That's crazy. What I do to solve that? I don't even know. I'm gonna pause it. All right, so I was bummed out. I didn't know like how to fix my problem. But so I went to the problem section, to the solution section, and I found this solution, and it makes total sense. Because the way that I was thinking about it is that maybe I can solve this by saying, okay, go to the right, and then okay, so have a pointer at the right, and then find the least by saying like, okay, I mean find the pair that is the tightest pair. So like with 11 and like limits 12, like okay, so do like 12 minus 11, or the 12 minus the current the one of the pairs, right? To and then do binary search to find the difference. But literally we can just do this. But yeah, my brain has been overcomplicating things recently. I forgot what problem I was working on later. I mean earlier this morning. But yeah, this is literally the same solution that that was something that I was stuck up on. Yeah, it makes sense. So basically, this guy explained it really well. But in my words, I would say, okay, so get a left and right, or low and high. But I like to do left and right because I'm used to it, right? So get a left and right. Find a pair where right plus the value of right and left is equal to limit, or less than equal to limit. And then if that's true, then make that a pair. And then shrink down the list. So move right to 10 and left to this next one, and then keep on going. But if that's not a pair, then just move right once, right? So and then at every iteration we're going to have a boat either way until until left and right are until left is more than right at that point, kind of like binary search, right? You stop when left is more than right. So that's kind of it. I'm kind of sad that my solution didn't work, to be honest, but that's fine. So yeah, it makes total sense to me. So I'm just gonna code that up, and yeah. So both equal to 0, people that sort, cool. Length of people, and then we're just gonna have 2 pointers basically. Oops, what the heck? Okay, so I misclicked my backspace button somehow. So yeah, we're gonna have a left and right pointers respectively of their a -1. Okay, and so while left is less than right, can they be equal to? Yeah, they can be equal to. Because what if they're odd, right? So I mean, what if the amount of people is odd, right? So so while left is less than equal to right, so if people, oops, I just make it shortened down. So if people at left plus people at right is less than equal to the limit, then we're going to acknowledge that they are a boat, right? So every iteration we're gonna make that a boat either way, because we can have not a pair and we can have a pair. Um, and even if in their conditional statements, I can just say boat plus plus, but just to make it more efficient, I guess it makes sense to just have boats plus equal to 1, right? And so if so if they are a pair, we can just shrink in the list down so we can get the next pairs if there is any. So left is gonna get incremented by 1, and then right is gonna be decremented by 1. Then else we're just gonna move right until we find like a tight pair. So -1. Right. And that should be it. Then we turn the boats after this while loop. I'm pretty sure we don't need this anymore. Yeah, we don't need that anymore. So that's pretty much it. Just run this. Oh, oops, boats. Okay, so it works. Submit. Awesome. Yeah, so that's pretty much it. Um, Good thing you guys went through my solution process. If you watch this video fully, that only took like 5 minutes or 10 minutes to like think of like what could I do, but I didn't want to. Yeah, because I'm really stressed out right now. But anyways, whatever. So that was my solution process. I had to look into solutions, but almost got it. Almost got it. But I hope going through my mind early on in this video was pretty helpful. But yeah, so we kind of reviewed and everything, but we gotta evaluate this. So basically, this is, if you look at it, for space, we're using O of 1, right? We're using O of 1 space, I'm pretty sure. Unless this sort function does something, I'm pretty sure it's O of 1 space. And then, yeah, O of 1 space from my perspective. You know, if I was in an interview, they'd probably say, actually, no, that's like O of 4 times n or something like that. And then for time, where we're iterating through every element of the list, so it's O of n. But yeah, it's pretty fast, I guess. It beats quite a lot, but that could be RNG either way too. So yeah, so O of n, time, O of 1 space, or it could be O of n space too. I'm not sure what this sort function does, but yeah.